Good evening, students. In last class, we discussed various relational algebra operations like unary operations and set theory operations. In this class, we are going to discuss various binary operations like join operations, division operations, and intersection operations. So already we completed intersection operation last session. In this session, we will concentrate only on join operation and division operations. Okay. Coming to this session, in join operation, we have three categories, okay, called as natural join, outer join, and equijoin. So natural join is also divided into two categories called as condition join and theta join. Okay, based on theta join, we will get equijoin. If you study the natural join, based on natural join, okay, we will get two joins called as conditional join and theta join. So natural join is also called as inner joins. Okay, these are the inner joins. These are the outer joins. Inner joins are natural join, condition join, theta join, and equijoin. Outer joins are left outer join, right outer join, and full outer join. Okay, so the reason for join operation is to merge the two or more relations based on the tuples. Okay, so that if the attributes has to match or not, based on the tuples, we merge two or more relations based on common attributes. If there is common attributes, automatically we can merge based on the common attributes. Otherwise, we'll merge two or more tuples based on your condition. Okay, right. Next, first coming to this, first is natural join. So already we discussed that it is a binary operator. It is a binary operator which takes the relation between two or more relations which result set of all combination of tuples. Okay, we get based on the combination of tuples. So we know that the set of combination of tuples is based on one important one important operation called as Cartesian. So Cartesian product is combination of all the operations, combination of all the tuples where they have equal common attribute. If there is a common attribute, based on common attribute, the tuples will be merged. Okay, see, this is an example. We have an employee relation, we have a department relation. So employee relation consists of three attributes and department relation consists of two attributes. Okay, in two relations we have a common attribute called as department name. Okay, we use a symbol called as like this. This is a symbol for joining operations. Okay, so if you join these tuples, altogether we get 1 into 3 products. Okay, 1 into 3. Next, 1 into 3 means IT is matched with IT. We get a value. Okay. Next, if there is a common attribute with common tuple, if there is a common attribute with a common tuple, so a common attribute is department number. Common tuple is nothing but the value which lies inside this and inside of this value. Okay. If there is no HR value, means here in this relation, we will just skip that relation. Okay. Next, if you go for the sale, there is a sale, so that we map the relation. And last one is if there is IT, so that we map relations. So we have a four values in one relation and the 3 values in one relation. If we combine these 7, we will move one value with one value. So there is a 2 values and duplicate value, so that we remove the 2 values. Okay, we get a 3 values of data. I hope you understand. Okay, tuple with tuple, tuple with tuple. This is IT, it is a tuple mapped with A. Next, HR, there is no HR, omitted. Sale with Y. Next, department, IT with IT. Okay, I hope you understand the natural join. Here we see in natural join there is a loss of data. Okay, because the relation consists of HR, the relation consists of production. So both are removed, so that the data is lost when you use the join operation. Okay, next, coming to condition join. Here there is no condition between two relations. If you maintain a condition, then the condition, based on the condition, the relation will perform. So that is called as conditional join. So the conditional join works, it is similar to natural join. In natural join, by default condition is equal between common attribute. While in condition join, we can specify some conditions. Based on some conditions, like nothing but use some operators. Based on that operators, the condition will perform. That is called as conditional join. Okay, consider this is a relation and this is a relation. If you use the relation by means of some condition, this is the condition. Condition that relation marks greater than S marks. See, why we use this operator means here we have a marks. Here also we have a marks. So that to understand which marks we are taking in a relation, so that we use dot operator. So that based on this dot operator, we can access the particular relation. The syntax for this dot operator is relation name with alias name dot attribute name. Next, relation name with alias name dot marks attribute name. Okay. See, if there is a relation called X or called DBMS. Okay. For accessing that attribute DBMS, we use alias name as D. So that D dot marks. So here the student means we use alias name as S. Okay. Either we can use any name, but we generally take first alphabet of your relation. Okay. If you see this one, if you combine these two relations, first it takes a Cartesian of these two relations. Okay. First, that is that Cartesian of this include 1 with 3, second row with 3, third row with 3. Okay. So overall I will get 9 values, 9 tuples in our relation when we combine. Okay. After combining we get 9 values. Then if you use the particular condition, it automatically removes after getting the Cartesian values. Okay. It first checks the Cartesian of first value with this one, second value with this one, third value with this one. Okay. Next, first value with this one, second value with this one, third value with this one. So whatever the condition checks, it will takes into the relation output. Otherwise it will defaultly remove the relation. Okay. If in this particular condition I have to join based upon the marks in two relations with condition our relation marks greater than or equal to S dot marks. Okay. So it should be greater than this one. So first it checks with 45 with 20. Okay. Condition true. 45, 22, condition true. Next, condition false. So it automatically remove. Next again, checks true, true, false. So 1, 2. Next 60, greater than true, greater than second relation. Next true, next true. So okay, total we get how many? 1, 2, 3, 4, 5, 6, 7. This is the operation and the process of conditional join. Okay. Next, if you move to the another concept, this is the same as like this. So already we say that it should not be same. Attribute should not be same. Okay. The values must be common. Here the values must be common, not attributes. Okay. Right. See, if I say that if I say a particular condition that find director comma actor pairs where the director is younger than the actor. So director is younger than the actor. Okay. So first, if I use sigma, that is not, but all the values will come. If I want only these two values means I will get only particular attributes. Okay. So that see, I want director's age greater than actor. So that first 954 greater than compare with this one. Next 56 low. Next less. Next less. No. 45 compare with this here. 45 no. Next no. Next no. Next no. So first checks with 4. Next checks with 4. Total 8 operations are happened. Next 59 with S. It is rhyming 1959. So it is 1954. 1959 is less than or greater than less than. Okay. So it happened. Next 59 greater than. So it is taken. Next less than. Next greater than. So we get total how many? 3. Total 12 operations. 12 operations we get only 2 values. If you take the particular this one, sigma of R into S. If I say pi of the values means I will get only 2 column names instead of getting all the values. So sigma refers to tuples. Next, pi refers to attributes. I am saying that pi of director and actor, not all these things. so that I get a director and actor only, so that whatever the conditions true is these two conditions, 1, 2, 1. Okay, so this is condition join. So the as same as condition join, theta join also same. Okay, here we use only greater than symbol, but theta join means we use all the operators like greater than, less than, greater than, equal to, less than, equal to, equal to. If it is equal to means it is equijoin. Okay, next theta join. So it is also used to merge two tables based on condition represented by theta. Theta joins work for all comparison operators as we discussed. It is denoted by sigma symbol theta. But here we see the symbol with C represent condition. So the condition is only for greater than, less than, not equal. Only three operators. Okay, less than, greater than, and not equal to. Greater than, less than, and not equal to. Okay, greater than, equal to, less than, equal, not equal. Whereas if you take theta join, there will be all the operators. Okay, if you take theta join, we have a student record, one relation, and the subject registered, which is another relation. Total how many possibility if you maintain, if you use a Cartesian product means directly it is happened, but actual process is like this. Actual happen is like this. So we have a 6 records. Total how many records? 2 into 3. I get a 1, 2, 3, 1, 2, 2 with 1, 2, 2 with 2, second one, 2, 2 with 1. Okay, automatically 6 records. After getting the 6 records, now you apply the condition. Is also same. Is also same. Is also same. After condition, after getting the Cartesian product, now you apply the condition. What is the condition means? Register number equal to S register number. Okay, S register number equals to this register number. What is this? Is equals to this is what? Not equal to, not equal to, not equal to, S equals to, S equals to into this one theta. Already we discussed that. We say that car price greater than board price, so that we get a this relation with this relation and this relation with this one and this one. So total how many? 3 with 3, 9 relations. Among 9 relations we get a only 4. 4 is the condition satisfied values. Okay, if it is only equal to means it is a equijoin. Okay, that is example here. This is the example of equijoin. Okay, this is the example for theta join, which condition less than, greater than, equal to, less than, equal to, greater than, equal to, not equal to. Next, coming to outer joins. So the outer joins are the solutions of your natural join. That is, when you process the operation between these inner joins means we are losing some data. So identify which is losing the data, which relation is losing data can be understand to the user by means of outer joins. Okay, see, theta join consists of equijoin and natural join. These are the inner joins, and inner join includes only those tuples with matching attributes, and the rest are discarded in the resulting relation. Therefore, we need to use outer joins to include all the tuples from the participating relations in the resulting relations. So there are 3 kinds of outer joins: left outer join, right outer join, and full outer join. If it is a left outer join, it should be represented like this. 2 parallel lines is maintained at left side. If it is right means parallel lines placed at right side. If it is full outer join means both sides we use the parallel lines. Okay, so first one is left outer join. That is, we combine these 2 relations in based upon what will happen in inner joins. Whatever the values that are available in left outer join will be available. It should not be removed, and whatever the right values is not available means it is as represented as null values. Actually, this is represented by dashed lines, but actually it is based upon the null values. Default, it takes the null values. See here, left consists of AB, right consists of 2 relations which consist of 2 values. Common attributes is A. Okay. Now we combine with these attributes, we get 100 database 100. Alex, next. Next one is 100 database. There is no 100. Next, we combine with 101 mechanics with there is no value in right side. So that we place 101 mechanics There is no value here, so that we represent by means of a dashed line. Okay, next 102 electronics with 102 Maya. Okay, so we have the 100 relation, 101 relation, 102 relation. Okay, but right side we do have only 100 and 104. What is the data not available means 104. That is represented here. That is represented here because 101 is represented with, okay, 101 has a data, 101 data is not matched with 104 data. I hope you understand. Okay, whatever the data available at left side and whatever the data not available, the next relation will be represented as null value. Okay, if you take the right join means if it takes 100, 102, 104 here, and which is data not is common between two relations means 101. So that 101 will be represented as dash. If you combine full outer join means we combine these relations so that we don't have the value of 101 here. We don't have the value of 104. We represent 101 here. See, 101 represented here, so that it should not be mapped with the other one here. We can understand that 101 is at left side means there is no data combined with right side. Here we have a 104 data that is not available at left side, so that we can easily understand which data lies at left side and which data is lies at right side, so that the user will understand that this is not a common data between these two relations. Okay, next, as we discussed, next division operator. So already we know about the set difference operator, but this is the one important concept we will discuss now. So division operator is represented by A division B, can be applied if and only if attributes of B is proper subset of attributes A. So B is a proper subset of attributes of A. The relation returned by division operator will have attributes, that is all attributes of A. Already we know the set difference. All attributes of A minus all attributes of B. We are set differencing all attributes of A minus all attributes of B. A is a relation, B is a relation. Okay, the relation returned by division operator will return those tuples from relation A which associated to every B tuple. We will discuss now. Okay, so we for using the we will take the SQL operator as all operator. If you are performing division operator means the SQL operator is all. If you are saying that I have to get all the names of particular relation means we use a division operator. See, that is some example. Which person has account in all the banks? Which person has account in all the banks of a particular city? If I want all the relations in particular concept, then we use a division operator. If which students have taken all the courses required to graduate. So in above specified problem statements, the description of the keyword all defines a set which contains some elements, and the final result contains those units which satisfy these requirements. So I will check all the relations, all the banks. So all the banks, checks the first all the bank. If it is available means then it plays. Okay, next, it is not available means just it should be omitted. Another way is used nothing but if then. There is a statement called as if then. Okay, see, this is an example. The relational algebra consists of a division operator returns every tuple from R that match all tuples in S. R and S must be division compatible. Okay, see, R divided S, let R be completed and S be a DB project. I have a completed of one relation. This is the second relation, so that these two relations will be divided. So see this one, Fred. I want these two tasks is the task of this DB project is have to perform these two. Okay, Fred performing database 1 and database 2. Fred performing database 1 and database 2. So we get a student called Fred. Next, Fred compiler. Next, using database 1. Using compiler. He is not performing database 2. So that he is not performing all. So that he removed. Next, Sarah database 1. Sarah database 2. So after performing completed relation with DB project relation, Now you get only two names called as friend and Sarah because these two are all performing the relations. Okay, I hope you understand the relation algebra. Okay, coming to the next topic is relation calculus. Already we discussed relation algebra. So relation algebra is a procedure query language such that we have to specify what data to be retrieved and specify how to retrieve. Whereas in non-procedure query language, we tell the system what to be retrieved. We should not give any information about how to retrieve. Okay, the process we will see now. So the types, we have two types of relation calculus called tuple relation calculus and domain relation calculus. The tuple relation calculus specifies the select the tuples in a relation. Only it takes the tuples in a relation. Okay, as like as a selection operator in relational algebra. Whereas in domain relation calculus, we retrieve only attributes or the columns of your relation. Both in these both tuples we use filtering variable. Filtering variable is a variable where we can take as an alias operator of your relation. Okay, so that here we use some connectivities called logical and or not, and also uses various extensional quantifiers and universal quantifiers for binding the variables. Okay, first coming to relation calculus, tuple relation calculus, it is used for selecting those tuples that satisfy the given condition. We use a syntax called as t by p of t. Already we say that t is a tuple. Okay, our table, this is a table name, p of t is a condition, so this is a variable. Variable maximum will be your relation. Okay, so here we see a tuple variable is nothing but a name, can be anything. Generally we use a single alphabet for this, so let's say t is a tuple variable. So in this form of relation calculus, we define a, first we have to define a tuple variable. Next, specify the table name in which the tuple is to be searched for. First we have to identify the tuple variable. Next, to identify the, after identifying tuple variable, you have to specify the table name in which the tuple belongs to along with condition. Okay, to specify, we can also specify column name using a dot operator. Dot operator means it is a column. Okay, next tuple value means is based upon a tuple variable. Okay, to specify the name of the relation in which we want to look for data, we do the following, that is relation of t, where t is our tuple variable. See, this is constant. See, like this, we have a relation. We have a, in this relation I want to display the last name of those students where age is greater than 30. So I want the display the last name of the students where age is greater than 30. So here we see. So I want the last name is this. This is the attribute name. Okay, tuple name is t. We can return tuple name or tuple variable with attribute name by means of dot operator. I hope you understand. T dot last name slash, where the relation means by condition means this is the tuple variable. Tuple variable already we discussed by a tuple variable with the column dot operator. Okay, t dot last name slash student, that is condition. This is the condition. Condition means how you get by means of a table name, and we use what we use, say that connectivity operators. We say the connectivity operators called AND here. AND. Okay, student of t and t dot age greater than 30. This is a condition. I want this one, so that this is a, what we calling, this is a attribute. Attribute can be represented by means of tuple variable dot attribute name by condition. Condition is age greater than 30. Age greater than 30 is this one. We can access by means of tuple variable and use a connecting operator with relation. Relation is student. Student of t and t dot greater than 30. I hope you understand. So that we get a value of only greater than 30 means what? Sing 31. This is the result. Okay. Now same thing is this one. We can use like this. T slash student of t and t dot last name. I want only last name is equal to Singh. So I am retrieving Singh, so that I am directly writing here. If I want age means here we use a t dot age. Display all the details of the students. So now we will get all the values. All the values of the attributes. If I want particular attribute means I will write here. Tuple variable. Okay. In tuple variable we can retrieve particular data. Here we use a condition. I want all the tuples which consist of Singh, so that there is no all the values means directly we write tuple variable. Okay. Next we are going to domain relation calculus, as same as relation calculus, but the difference here is we use all the tuple values with the function values. So this is one. See, if you use here only either one, okay, if there is no either one or all. If I want two or more variables means it is not possible. So that we use a domain relation calculus. So that here we use more number of attributes. We use a function. Okay. See, here we use a C1, C2 represents more number of columns, and that defines the F defines the formula for getting the condition. Okay. So the symbols we use here is already we discussed. For example, I want name and age. See, above query will return the name and age. So I have two. What we do two means I am getting two attributes. Okay, two attributes in the stable student who are older than 27. So here we use, instead of here we use tuple variable, we are using some condition. This is the all attributes I want. By syntax is function. Function means this is the function. We are using function here. The function is nothing but same as there is no tuple variable means here also we are using only student name